So now moving on to the data types. After explaining this declaration in C, I hope this is very clear in your mind, very clear and very simple. Now we'll go to the data types. So what are data types? I already told you what are data types. Data types in C defines the type and size of the data that variable can hold. Okay. So there are three types of data types. That is a basic data type, a derived data type, and a user-defined data type. Okay, three types of data types. The first one is basic data type. So what is basic? Like I told you now, the int, float, double, char. These are the data types which I've used in previous programs. So you can't say that you don't know. I've already told you from the starting of the programs what is int is integer. So please keep in mind these are the keywords you have to learn. Float, what is float? Like when you have to write the decimals. What are char? They are the character. Okay. What a double? Double means the long precision of float. Okay. So I hope you now you are familiar with these terms, so you don't get like what I'm telling. So these are the basic data types. Okay. Int, float, double, char, and void. Okay. So what int does? Int stores integers like whole numbers. What float does? It stores decimal numbers with single precision like 3.14, 25. What is double? It shows large decimal numbers, double precision. Okay. Like this, I told you now. Like if I like I explained you very simple, like previously also now also. That if this is float, this is double. You saw this? This is a small size, this is a bigger size. You can show more numbers. And in like in formal terms, we will say like it has double precision or more precision than float. The meaning is same, the work is same. It's just it stores more numbers. Okay. And another thing, cat stores a single character. See, and void, it represents absence of a value. That is void display. I hope you understand all these types very clearly and very precisely. So let's go. And what is this? I told you previously. This is declaration and initialization. I've declared int age and I've initialized it with 25. What is this? Declaration and initialization. What is this? Float pi I've declared and initialized it with 3.14. What is this? Declare and initialization. I've declared double variable and I've initialized it with 12.3456. Okay. I hope you get clear this whole thing very nicely. I've interacted it very nicely. Okay. So like these are the notes I've written myself. Like, yeah, I hope you like it. Then we'll go to another data type that is derived data types and user-defined data types. Okay, let's go. So, what are derived data types? They are built-in data extensions of data types. Okay, these are basically the extensions of data type. In this, we can include arrays, pointers, functions. I'll tell this in the further video because these are the like little bit advanced things. You won't understand it right now. So I'll just give an overview. These are the built-in data extensions of basic data types. To organize or reference existing data types in advanced ways, they use standard memory layouts. It like int marks. This is the array. Okay, this is array, and this is pointer. You won't understand right now, but you can just like see and read. I'll explain the further video. Now, mostly based on the same type of elements manipulated and executed data efficiently. Now, what are user-defined data types? These are created by the programmer using built-in primitives. Okay. This is used to define custom data structures or aliases. What are the keywords? Struct, union, enum, type def. It can be customized in and example is like struct student. This is a structure. I will tell you further. This is all advanced thing. You won't understand it right now. This is like it's defining. It is very flexible, allows grouping multiple ways. Main use building real world models. Okay. So I hope you understand there are three types of data types. The first one which you are using is very clear in your mind. These two will get clear with the end of the video as I'll tell you about the pointers, functions, and structures and unions. Okay. So now let's go and move on to the operators. What are operators? You know, you have studied maths like these are the operators. These are the operators. You have already studied maths. Okay. So let's first go to the arithmetic operators. Operators are like they perform operation on variables or constants. These are the two variables, A and B. So they'll perform operation like A plus B, A into B, A divided by B, A modulo B. Okay, these are the functions of the operator. So like first operator is arithmetic operator. So you can see the things like it is addition plus subtraction minus multiplication. In maths, we use multiplication like this, but in like computer language, we have to use this S star. And in division, slash and modulus mean remainder. Okay. Now you can read this table. It's very simple. I don't have to read it. Now these are the two variables, and the operation is being performed. This is the arithmetic operation. Okay. A plus B minus B A star B, A divided by B, A modulo B. So now if you understand this, I'll write a basic program so that you will understand this. So first hash include stdio dot h. You know this very clearly. This is the fourth time I'm telling you. This is the last time I'm telling you what is this. This is the preprocessor directive. Without this, library functions like printf and scanf won't work. Okay. So now int main starting of the program. There the program starts curly base. And now what is this thing? I have declared and initialize these multiple variables. Okay. Int a is equals to 15, b is equals to 4. This means this value of 4 is getting stored inside b, and this value of 15 is getting stored inside a. Okay. These are the two variables. Okay. Now you understand. And the data type is integer, and the keyword is int. I hope this is very clear in your mind that this is the previous of the directive, and this is the starting of the program, and this is the keyword data type is integer. These are the two variables which are being declared and initialized by some values, and these values are getting assigned to the particular variable. Okay, now let's move on. Printf. We have to print this. Now, I told you about format specifier, if you remember. Now, here we are going to use it. Why? Because here we are using keyword. So, to print these things, we have to use the format specifier. Now, you'll get a clear understanding what the format specifier is. So, let's go. Printf. Uh, double quotes, addition. Like this is the thing which will get printed. This is the thing we are writing. Okay. So on the screen, it will get printed like this. Not this double quotes, but inside the double quotes, that is addition. And this thing. This thing is we are writing, this will get print 100%. And after this, there is a format specifier. You can see percentage %d. And if you remember, percentage %d is the format specifier for integer whose keyword is int. Okay. And I told you about this thing, if you remember. Forward slash and this means new line. Okay. So now all this we'll see here. Printf addition format specifier. This means this value of a plus b will get printed here, and then the line will end. And this is closing, which means the things which are inside this will get print. Now, comma a plus b. This means print a plus b. Now I'll tell you what is the output of this. This means addition. I'll tell you the output. Okay, output. Please see nicely. Wait. Output is equals to addition. Wait, sorry. Addition and 15 plus 4, it is 19. This is the thing which is going to get printed. This thing exactly. Why this thing? This is the thing we have written here. See here. Okay. And what is this 19? This 19 is the format specifier. Okay. Percentage D. 15 plus 4. Okay. Now I hope you understand this thing. Now, like same, it is also written with array. Wait, sorry. This thing is also written subtraction, format specifier, line and a minus b, multiplication, format specifier, line and a into b, division, modulo. And after that, I written 0. Why written 0? Because I have used the int. So I hope this thing is very clear with the program, how to use arithmetic operators and what is the role of format specifier. The role of format specifier is to print the numbers or the to print the data type. Okay, if you are using int, then it should get percentage d. If you are using characters, then it should get percentage s a percentage c. Okay, so now we move forward. I hope this thing is clear. If it is not clear, then see this video again because I've done it from the very basic. Now we'll go to relational operators. Now, relational operators are used to compare two values. Okay, what we used to compare? Two values. How you compare? Greater than, less than, greater than equal to, less than equal to. These are the only possible things. Okay, and not equal to also. In maths, we use not equal to like this, but in computer language, it is exclamatory mark and equal. This is not equal. Okay. What is this? This is not equal. So now we'll learn about relation operators. It is used to compare two values. The result is either true or false. If it is true, then it will 1. If it is false, then it is 0. So now let's see. Equal to means not equal to doesn't mean this. Equal to means equal to equal to equal to. This means because a single equal to means assigning the value. Now, like see, a is equals to 2 means this value is getting inside a. This value of 2 is getting assigned to a. But a equal to b means a is equal to b. Okay. So keep in mind, don't use equal to like this. If you want to use equal to, then use equal to because this is used to assign the value to a variable. Okay. Now let's move forward. This is equal to. This is not equal to, like I told earlier, exclamatory mark and equal to sign means not equal to. This is the greater than. This is the less than. This is greater than equal. This is less than equal. Now there are two variables we are using. This means a is equal to b. This means a is not equal to b. This means a is greater than b. This means a is less than b. This means a is greater than equal to b. And this means a is less than equal to b. Okay. Now, for example, they have given two variables, a is equals to 5 and b is equals to 3. Now, it is saying a equal to b. That means the value of a should be equal to b. If is it is 5 equals to 3? No. So it is false. And if it is false, then it will get 0. Like I told you that if it is 2, then it is 1. If it is false, then it is 0. Like here. So it is false, then it is 0. Okay. Like a is not equal to b. 5 is not equals to 3. That is true. So it will come 1. A is greater than B. 5 is greater than 3. Yes, it is true. So it will come 1. A is smaller than B. It is true. No, it is false. So this will become 0. A is greater than equal to 3. 5 is greater than 3. Yeah, it is true. A is less than equal to B. It is false. I hope you understand the relational operator very nicely. So, like, I don't have to write the program every time, but I'm writing for your understanding. Like, it is a very basic thing. Like, this thing I written here, write down only. So, include stdio.h. I won't tell you again. I've tell you multiple times. Now, int main, I'll tell you multiple times. This I'll tell you because this is important. Int a means we are declaring and initializing the values of multiple variables with 5 and 3. And then printf. This will get printed. See, here we are using format specifier percentage %d y percentage %d because it is a int. So print a equal to b. This will we have written it with our own hands. This will have given it percentage %g. So this is the output. Why 0? You tell me why 0. It's 0 because it's false. Okay, it's false. Why 1? Because it's 2. So once see this and try to understand with your own by the time I am making you understand. Okay. So here a equal to b, but 5 is not equal to 3. That's why it's false. Now here a not equal to b, percentage g slash n. A not equal to b, that is true. So b has the value of 1. Here a is greater than b. It's true. That's why we have the value of 1 again. A less than B, it's not true because A is 5, A is greater than B, so it's false. So it comes 0 here again. Now, A greater than equal to B, that means 5 is greater than 3, that is true. So here comes 1 again, and again here comes false. And return 0 is for int main, returning a value. I hope you have the clear idea of relation operators also now. The code is also very simple and basic to make you understand. Now let's go to logical operators. I personally don't use this much, but let's let's get understanding of this also. So what are logical operators? These are used to combine or invert conditions, okay? They either return like true or false, like just like the relation operators, they also return true or false. Okay, so let's learn about this. They are basically mostly used in decision making, like in if and while. You don't know if and while, I'll explain in further videos. Like they are the loops, if and while loop are the loop statements, and they return either one if true or false, 0. Okay. So, I and like if you have studied like basic electrical engineering, B triple E in your subjects, then you must have known AND gate, OR gate, and NOT gate. They are like that only. Okay. So let's see this. It will get true if both conditions are true. ठीक है? Two conditions are given like A is greater than 2 and B is smaller than 5. If both the conditions are true, then you will get the print 1. And in logical or, if at least one condition is true, then you'll get print 1. And in logical not, reverse the condition, reverse the result, then you'll get 1. Okay. Now we will go to assignment operator. What is assignment operator? I told you previously, no? Equal to is an assignment. This is a basic, it is the most common assignment operator. The AO means assignment operator. Now we have variations in this, like plus equal to, add and assign, minus equal to, subtract and assign, equal to plus, assign and add, equal to minus. Like pre-assignment, we can say like a pre-assignment operator or a post-assignment operator. Like pre-increment, post-increment, like this thing you have heard now, they are the same thing. Now let's go. Plus equal to means add and assign. First, the value will get added and then assigned. Okay, let's see. A is equals to A plus 2. Add and then assign. Okay, plus equal to means this. A plus equal to 2. This means this. First, add this thing and then assign the value to A. Minus equal to means subtract and assign. See, first subtract A from 3 and then assign the value to A. Multiply equal to means first multiply this thing and then assign the value to A. Divide assign means first divide this thing and then assign the value to A. Percentage equal to means first find the remainder of this and then assign the value to A. Okay, so this is the like basic thing. You must have like clearly understand it this. This is the pre-increment operator. Okay. Now let's go to bitwise operator. It performs operation directly on bits. Okay. It is used for low-level programming languages or low-level programming devices like drivers or embedded system. Okay. You can see this and XOR. Again, XOR gate, NOT gate, left shift, right shift. Again, that if you have studied BEEP, then you can easily understand this thing. Okay. Now talking about the if statement, it basically is used in decision to C program. Like it will only run if the condition is true. If the like here it is saying this block of code, it will only run if this condition is true. Okay, so basically it is a statement which is a fundamental control structure in C, which is used to execute a block of code only where specified condition is true. If this condition is true, then this block of code will get executed. Okay, so it is written like this is the syntax basically. This thing is the syntax of the if statement. So how to write it? First, you have to write the if itself. Then the condition will come. Condition. Then curly braces. Then here will be some block of code which you want to execute if the condition is true. Okay. Then we will close this curly braces. So this is the simple if statement. You can see the syntax. Now, for your better understanding, we'll take an example. Like this hash include stdio.h. You know what is it? It is a preprocessor directive. Preprocessor directive. Without this, the library functions like printf and scanf won't work. Okay. And now this int name, int is the starting point of the C program, as I told you earlier. Then we are taking int age. Int is a data type. Age is the variable name, and this 18 is the value which is assigned to the variable. So basically, we are declaring and initializing it with 18. Then the semicolon is used to terminate the line. Okay. So like here, I have declared and initialize the age, and then you can see below. This is the if condition. Okay, and this is the condition. If the condition gets true, then this statement will get printed. Okay. So in this case, it is given that age should be greater than equal to 18. And if it is greater than equal to 18, it will print you are eligible to vote. Okay. Then we'll close this. This is for the if statement. Okay. This curly braces. Then return zero. Why return zero? Because we are taking int main. And in int main, we expect it to return a value. So if we get zero in return, then the code is successfully executed. Okay. So this is the basic example. I'll tell again. We have taken int age is equals to 18. Now, if the age is 18, this condition gets true, then it will print you are eligible to vote. Now, suppose if the if condition is false, then what happens of the block of code inside? So in that case, if the if condition is false, then the block of code inside is skipped and nothing happens. Nothing will get printed. Okay. So this was about the if statement. Now we have the if else statement. Okay. Now in this case, we have if and then we have a condition. Then we have curly braces. This is of the true block. Okay, like if the condition gets true, this code will get executed. Otherwise, we'll close the curly brace and then we have else condition. If the condition is true, this block of code will run. Otherwise, this false block of code will run. Okay. It's simple as is like in if else, first we have if and then the condition. If this condition gets true, the below code will run. Otherwise, if the condition is false, the else code will run. Okay. Now, in this case, your program allows you to choose two paths. One is the true condition path, and another is the false condition path. If the condition is true, the code will run. Otherwise, else code will run. Okay. Now, we'll take another case of if else if. In this, again, like they are exactly the same, but condition increases. Like in this case, if has a condition one, if this is true, block one will run. If it is not true, then you have condition true. Condition two. We will check the second condition. If this is true, then this will run. Otherwise, else code will run. Okay. I'll explain it again. Like we have the first condition. If it is true, then this block will run. If it is false, then we'll check the second condition. Now, if this is true, then the block two will run. But if both are false, then we have a default block of code to run that will run. So this what about the if else and if condition. Okay. Now we have the last if, that is the nested if. Nested if. So in this case, we have a if statement inside another block of if statement. It's basically like having a block of code inside another block of code. So it's basically like a nested if is an if statement inside another if or else block. So we see it here. We have a if condition. This is condition one, and we have a block of code. And then we have another if condition and another block of code. But we have a condition here that the inner block will run only if both the conditions are true. For this code to be executed, we want both of these conditions to be true. So in nested ifs, we have to print, then we have to make sure that the both conditions are true. So here is the example. You can see again, hash include stdio.h preprocessor. This is the starting point. Then we are initializing the marks and declaring the marks. Then we have the if condition that if the marks is greater than equal to 60, print the first condition is passed. Then we have a nested if inside if condition. That is, if the marks is greater than 80 also, then write excellent performance. And then we'll close this both the if conditions, then return zero for int main, then we'll close the program. Now this is the output. First condition is passed, and then the second nested condition is excellent performance. Okay. I hope you understand the example. Now we'll go to the switch statement. So basically, switch statement is an alternative to the is if else if. Okay. Like if we have multiple if else if, then we can say it's like a switch statement. It's an alternate. So in this switch, we have first for applying switch, the syntax is switch itself, then the expression, then the curly brace, then the case value one, then the block of code we want to run, then the break. Then we have case value two, then the block of code, then again break. If both the conditions are false, then we have a default code to run. For example, uh, we can see one example. Let's include hash include stdio.h, then int main. Then we are initializing and declaring int day is equals to 3. Then we are using switch statement. That is switch. Then expression, what is expression? Expression is J. Okay. Then the case one is that print it is Monday. Case then break. Then if we want to break now, it will keep running like this. So we have to make sure that we are putting break. Then the case two is print Tuesday. Case three is Wednesday. And default is invalid day. What will be the output of this? Output of this will be Wednesday. As we are initializing int day as 3, so third will be Wednesday. Now we have conditional operator, which we also call ternary operator, because it works with three operands. Okay, like you know what is operands? It's a short form of if else used to return value based on a condition. Okay. Now the syntax is like first we have the condition, then expression if true, or if the condition is false, then we have another expression for that. For example, here we are taking int main and we are initializing and declaring a is equals to 10 and b is equals to 20, taking multiple variables. Then we have int max. We have just declared it here. Then we have a condition that a is greater than b. If it is greater than b, then print a, otherwise b. So here you can clearly see that b is greater than a. So we'll get maximum as 20. Now, what's the logic behind is this? That a is greater than b is a condition. Okay. If it is true, then a is written. If it is false, then b is written. And now in this case, A is 10 and B is 20. So it's clear that 20 is bigger than A. So the condition is false. So maximum will be B equals to 20. You can see again at this example. So I hope this whole page is clear to you guys. Now moving to the next page. Now we have one of the most important topics in C, that is loops. So what is a loop? So basically, a loop is a control structure that allows you to repeat a block of code multiple number of times until a condition is met. Okay, so basically, basic meaning of loop is like we are stuck in a loop that a block of code is running multiple number of times until that condition is met. If the condition is met, then the loop will stop. Now, what it helps is it helps to reduce the code repetition and make programs more efficient. Now, basically, looping process in general has four steps. The first step is setting an initialization of a condition variable. Like we saw initialization, that A is equals to 2, like assigning a value. So that is setting and initializing of a condition variable. Then second is execution of statements in the loop. Then the third is test for a specified value of the condition variable for execution of loop. So we have to specify the condition also, like we were putting in a switch statement and if else statement. So we have to put condition here also, and at last we have to increment or update the condition variable, like I plus plus. Now there are two key points to know, like when we know in advance how many times the loop will be executed, we use counter control loops. Okay, when we use counter control loops, then we know the number of times the code will be executed, and the counter variable is known as counter. Then, if we don't know exactly how many times the loop will get executed, we use sentinel control loops. What is sentinel control loops? It is used when we don't know exactly how many times the loop will be executed. And the counter variable is known as sentinel. So it's pretty easy that counter control loops variable name is counter and sentinel control loops variable name is sentinel. So you can keep that in your mind. So now coming on to the types of loops, we have three loops, like a for loop, while loop, and a do while loop. So basically, when to use a for loop, I'll explain it. Like when number of iteration is known, like how many times we have to iterate it, it is known. Okay. And while loop again, when the condition is checked before execution, it is a while loop. Before execution of a code, the condition is checked. That loop is known as while loop. Okay. And what is do while loop? Do while loop is a loop uh, which runs at least once. Okay. When the loop must run at least once, we use do while loop. And it is an exit control loop. Why exit control loop? Because it is running at least once, only one time. Least of the time is none. And for loop and while loop is the entry control. They both are entry control loops. Now moving to the first loop, that is a for loop. The condition of for loop is first we need the syntax. That is, first you have to write for, then we have to initialize. We have to do initialization, like I said earlier. Then we have to put the condition, and then we have to update it. Okay, so this is the syntax. After this, there is a code to repeat. So this is the syntax for loop. And now moving to the while loop. In while loop, first the condition is checked before running of the code. Okay, so the syntax is first we'll write while and then the condition, and we have a code to repeat. So basically, this is the syntax for while loop. Then at last, we have the last loop, which is the do while loop. So in do while loop, it is mandatory for the do while loop to run at least once. Okay, so the syntax is do, curly braces, then code to repeat, then the curly braces are off, then while, and then the condition. So these were the three loops which are used. And why are we using loops? Because it helps to reduce the code repetition. Okay, I'm saying again, it helps to reduce the code repetition and makes programs more effective. So these are the three loops: for loop, while loop, and the do while loop. Now we'll see the loop terminology. Like I mentioned it earlier. What are the things? The four steps. Basically, we can generalize it into three. The first is initialization, starting of the counter. Okay. The second is the condition. Check whether to continue or not. The condition is met. And third is the update. Move to the next step. That is increment or decrement. That is I. You will see earlier. Further in the example, like it will be written I plus plus or I minus minus. So these are the update. So now, like we have a comparison table here for the for, while, and do while loop. So basically, for and while loops are the entry control loops. Okay. And do while loop is an exit control loop. Why exit control loop? Because the condition, the condition in the for loop and while loop is in the starting only, in the starting of the curly braces. And a do while loop, the condition is at the end, like after the while. So these are exit control loops. Now, for loops is used when number of iterations, you can read this table. Uh, this is the same table like read it earlier. So you can one see. So now, moving on to the increment and decrement operator. So basically, increment operator is like increasing a number by one. Okay. Like I told earlier that you will see increment like the update one. So I plus plus means that I is increased by one, and I minus minus means I is decreased by one. So just keep this thing in mind, like you have the idea of how loops work. So while using the example, you will see the increment and decrement operator. So here also, like there are two things. First decrement and then print like minus minus I. In this case, it will first decrement it and then print it. And in this case, it will print I first and then decrement it in I minus minus. This is pre-decrement and post-decrement. So now we'll move on to the break statement. The break statement is used to exit the loop irrespective of whether the condition is true or false. Okay. Like whenever you want to exit the loop, you'll use a break statement. Condition is true or false, it doesn't matter. So this is the break statement. This is the syntax as you can see. I is equals to 0, then I is less than 1000. Then you are using increment operator, I plus plus. Then you have program, normal program. And then if statement, the condition is there, and then the break is there. Okay. So this is the break statement. Now moving on to the functions. A function is a block of code which performs a particular task. Okay, it is a block of code which performs a particular task. A function can be reused by a programmer in a given programs any number of times. Okay. The program can access a function any number of times, the number of times he wants. Like we have a code here, like you can see this is a function prototype void display. We can use it any number of times. Then int when, then we are declaring a variable. See, this is the function called display. Now we have declared a function here. Now we are calling a function here, display. See, then again we are defining a function here. So this is the function. Now what does a function do? A function prototype informs the compiler about a function that will be defined later in the program. Okay. The void keyword indicates that the function does not have any return value. So this void in the function prototype, it shows that it doesn't have to return any value. Now the important points are like some important points like execution of C program starts from main function only. As I told you earlier, that main is the starting point of the C program. A C program can have more than one function. Yes, it can have more than one functions in a single program. Now every function get calls directly or indirectly from main. Yeah, this is the main thing. Like every function that you are calling is from main only. Now there are two types of function, that is library functions. I told you earlier about library function that are printf or scanf. What are scanf? Scanf is used to take input from the user and user-defined function. These are functions and which are declared and defined by the user. Okay. Now why use functions? Now we use functions to avoid the same logic again and again. So like we can recall function any number of times of the same logic. So it helps basically in writing less code to keep track of what we are doing in a program, to test and check logic independently. Okay. So this was all about functions. So basically what we get to know that function is a block of code that performs a particular task, and this block of code can be reused by the programmer any number of times in a program. Okay, any number of times. So now we'll come on arrays. It is also one of the most important topic, arrays. So basically, how to explain like an array is basically a collection of elements of same data types, which is stored at contiguous memory locations. Okay, it is the collection, like the thing to keep in mind is it is the collection of elements of same data type. Just keep this thing in mind, same data type. Like int, if it is int, then all the data type will be of integers only. No character can be involved in that. So it basically allows you to store and access multiple values using a single variable name with index. Single variable name with index. So now, like you can see, we have the syntax. So int marks, this is the array. 90, this is the array. Okay. This is the integer array. This is the character array. This is the float array. So these three are arrays. Now, how are you like identifying them? So you can see this braces here. So it is the collection of same data types. See, 90 things are there. So they are of integer data type only. 20 things are here. So they are of character data type only. 90 things are there. So they are of float data type only. So this is a float array. Now these values can be assigned to make array like this. Okay. So like marks 0, 33, like this. Now how you have to declare an array? Like you can see, the first you have to write the data type, then you have to give a name of the array, then you have to give the size. Like I'll give you an example, as it is written above, int. What is int? Int is the data type. Okay. Int is the data type and its keyword is int. Now we are giving name as marks and the size is 5. So basically you will look that integer is the data type, int is the keyword. So we are using integer as a keyword. Then we are giving name marks. Then we are telling the size of the array, that is 5. So this is how you declare an array. This is how you declare an array. So now how to initialize it? So to initialize an array, you have to first declare an array. Now you have learned how to declare it. Now you have to declare it here. Int is the keyword. This is the name of array and this is the size. Now here it is then 5. So basically, like I written 90, 85, 70, 88, and 82. Now, the things you are seeing here below, these are called the indexes of the array, like 0, 1, 2, 3, 4. These are used to access the elements. Okay, whenever you want to call an array or call an element, so you are going to use the indexes of this. Like you want to call the element 75. So you have to use the index 2 here. And you must be having a doubt, like if the size of array is 5, then how come indexes are 4? So we'll use a formula like n minus 1 for the last element of 4, 3, 2, 1, and 0. So this is how you initialize an array. I hope you understand it. Now to access an array, like how I told you, you can access array elements using indexes only. So indexes starts from 0, 0, 1, 2, 3, 4, as I told you earlier. So here is an example, like printf percentage d, we are accessing array, mark 22. So he's telling that print the marks of the second index. So what is the mark of second index? That is 75. So 75 will get printed. So whenever you want to access an array, you have to use index. Or basically you can update the memory also. Like earlier, the marks at second index is 75, but now I updated it with marks size 2, index 2 equals to 80. So now the third element will change to 80. It will not be 75 anymore. So this was basically how to declare, initialize, and access array elements. So now we'll move to types of array. There are like three types of array. 1D array that we saw uh, just now. Then we have 2D array that is int a, size of 3, size of 4. So it is basically like a table and grid. Or more precisely, you can say it is like a table and column. Like table, no, like rows and columns, like rows and columns. So basically 2D is like rows and columns. And then we have multi-dimensional array, the 3D one, in 2, 3, 4. So basically here I've done an example. I'll explain. So hash include, then int main the starting point. Then we are declaring and initializing the array, like int marks 5. This is the keyword, this is the array, and this is the size. So basically this is the index will be 0, 1, 2, 3, and 4. So these are the indexes here. Now I'm using a for condition here, for loop here. So I want to print the marks using a loop. So I'm using a for loop. So int I equals to 0. Now I is less than 5 and I plus plus. That is the update one. Updation. Then open the loop. Then student percentage marks percentage G. I plus 1 marks. Then I. Return 0. Output will be one mark 20, second mark 85, like this. I hope you understand this. So now the topic of array is over. Then we move to linear search. Now, what is linear search? Now to search elements, we are using search here. And there are two types of searches, linear and binary. So first we will look at the linear search. Now linear search is like it checks each element one by one from the start to the end. And the condition is that it works on any list. Either it will be sorted or unsorted. It doesn't matter. It will work on any list. So here is the example here. Like we're taking int main, hash include, starting point. Then we are initializing an array. Size is not given. So n is 5 and the key is 20. Like we have to find this 20. We have to find this 20. Okay. So we have used a for condition here. You can see increment. Then it will check. It will check each element from starting to the end. And if the condition is met, then it will print. And if the element is not found, then we will print 0. So it's like we are using for loop and to its condition here. So you can see this is the linear search. Now moving on to the binary search. The basic logic is that binary search divides the whole array. this whole array into two halves. Okay, to find the element. And the condition of binary search is then it should be sorted. It only works on sorted list. Either it should be like ascending one or either it should be descending one, but it should be sorted. Either it won't work. Okay, so we'll see one example. We have a hash include here, and we have then a starting point main function. Then we are initializing an array here. Okay, so in ARR, then we are dividing the whole array list into two parts. Then 0 is equals to 0, then I is equals to 4, then C is 20 here, then int mid, then the int min for 0. Now we have to use a while condition here also for the binary search. Now to find the mid, there's a formula that is low plus I divided by 2. So this is the formula for the binary search to find the key element here. So to divide the array into two parts, we have to use a formula low plus I by 2. Okay, mid is equals to low plus I by 2. After this, we'll get the mid value. Then the whole array will be divided into two parts. Okay. Now, if the target point, if the key is the midpoint only, then it will print that element found at the index. Okay, then we'll get one. But if the key is less than the mid part, then the high part has to change to the low part. The low part will remain the same, and the high part has to change. So it will be mid minus one. For example, we'll take it is already given here. This is the mid part. So, for example, if the key is on the left side of the part, so this high will change, like mid minus one. So if this is mid, then mid minus one. So this two will be there. And if the key is on the right side of the midpoint, then the lower part has to change. The high part will remain the same. The lower part has to be changed. That is mid plus one. So you have to keep this thing in your mind for the binary search. And at the end, we are using if found, the if condition that if not found, then print element not found. So this is was the binary search. I hope you understand it. And it only works on the sorted grids. And here is a quick comparison of both linear and binary search. Um, Linear search will work on any array, but binary search will only work on sorted arrays. Linear search is slow because it checks each element one by one. Binary search is fast as it divides the whole array into two parts. And code simplicity is like in linear search, the code simplicity is very simple. We don't have to use any loops and all and formula and all. But in binary, it is a little more complex. And in linear search, we can search roll numbers as it checks like one by one. In binary search, we can search sorted scores. So this was the binary search. Now, as you reminded me of like variables, so I told you earlier that there are like four types of variables. So three types of variable like local, global, and static. So here I'm defining it now. That I told you earlier that local variable is always declared inside a function or a block, and it is accessible only within that function or a block. And it is created with the function and destroyed when it ends. So basically, this is a local variable. This int a, this declaration and initialization of a, the value of 10, which is getting assigned to a. This is a local variable, as it is inside the main function, and it is declared inside a block. So this is a local variable, and it is only accessible within that function. Now, talking about the global variable, it is declared outside the function, basically at the top of the function, and it is accessible in all functions of the program because it is outside the function. So you can access in any program. Then it will exist as long as the program runs. For example, you can see uh, this no, it is declared at the top before the function, this function at int is equals to 100. So this is a global variable. So you can use it at any time. So this is the main difference between local and global variable. Now, talking about the static variable, static can be local or global, but it retains its value between function calls. If local, it's not reinitialized on every call. You can see this example, like hash include, then void counter, void by void, because we don't want any value to be returned. Then you can see this int main, and then y return 0 is here because we want the value to be returned. Y 0 because when it is successfully executed, it returns the zero value. And if it has any error, then we'll get a non-zero value. So this is the code of the static variable. You can see. Now a quick now and this is the one-shot video. So there is a quick comparison of all the three. Local is declared inside the function. Global is on the entire program. Static is inside a function, but it retains its value. Now, local is only the during function call. Global, we call it an entire program, and static also entire program. Now, the default value of local is garbage value. The meaning of garbage value is like it is undefined. Basically, garbage value is undefined, and the default value of global is zero, and static is also zero. Storage class is by default, which is default by of local, and global value shows as global, and static is static. So this was a quick overview of the variables, which I told you on the first slide of the video. So now moving on to the strings. What is a basically string is it is a sequence of characters and it is terminated by a null character. What is a null character? It is like a forward slash and zero. This is a null character. So string is a sequence of character, basically a sequence of character which is terminated by a null character, and they are represented as character arrays. Okay, character arrays. So now we have two methods to declare strings. The first method is of character arrays. Like I told you of arrays now. Like first you have to write the data type. So same way, we write a data type here. For the character, we have the keyword char, and the name we are putting the variable array name as name, and the size is 10. So like I'm writing it as Harshit, and I'm like terminating it with a null character here. Either I have to write it in this way, or like the method two is using string literals. This is the most common way we'll using in the entire program, like char name and now double quotes Harshit. In this, uh we were using character arrays, like single characters are there, and now here we are using string literals. So here we are not using that null character because it is automatically included at the end. So we are not writing it here. Now the common string functions we will see here. So first one is strlen that returns the string length. Like you can see an example strlen and double braces ABC. So we got the length as three as ABC111, that is three. Now the most used is str copy, which copies one string to another. Here we can see str copy B to A. So now this A will get copied to B. Okay. Then we have star cat that appends one string to another, star cat A to B. Then we have star compare, which compare two strings. And if it is equal, both the strings are if both the strings are equal, then we'll get a zero value in return. Then we have star ref, which reverses a string, not in all standard in all compilers. So now we'll see a small example of that. First, we have to use that hash include string also. So here are two like the processor. Like first is hash include str.h. The second one is hash include string.h. So we are using it so that we can use this string function. So int main, the starting point. Then we have char string one, char string two. The first one we have not given the size, and second one the size is 20. Then star copy str2 to str1. So we are just copying this string one to string two. The the string which is written after is getting copied to the string which is written earlier. Okay, so this is the thing. This was the code. Then we have some things to remember that always allocate an extra byte for null character. Then use percentage %s to print strings, and you can take user input with scanf percentage %s str or get str. Okay, so this was all about strings. Now, like we have the last slide of this page. Basically, it covers most of the C programs. So now we have structures. This is basically the last second topic of the C, and then we have no last third topic. Then we have unions also. So first we'll see structures. Basically, both are almost same, but I'll tell. In structure, the structure is a user-defined data type that allows you to group variables of different data types. In arrays, what was the thing? We were grouping variables, but of same data types. either of integers, either of characters, either of floats, or either of double. But in this, we can like group variables of different data types, like character, integer, float, all in a single function. That is known as structures. So basically, the syntax is like we have to write struct, then we have to give a name. Like we'll give the name as uh we'll give the like student info. Like I'm writing struct student info underscore info. So this is basically the name of the structure we see defined. Then we'll open the curly brace. Then we have to write the members, member one, member two, member three, member four. Okay, like you can see here. The first data type, like the first member is int marks. Okay, int marks. The second is char, then we write tame. The third is like float, then CBA. Like always, we can use structure. So basically, we can take different data types under a single variable. Okay, different variables of different data types under a single function. So this is known as structure. Now, how to declare it? You can see here, like I told you earlier, struct, the main keyword of the structure, then the name, student, S1, S2, S3. Okay, this is like you have to declare it here. Then why use structures? Because like we can use multiple data types like group, integer, character, float, etc. And it is like organized data, and it is reusable and create multiple variables of the same type. Then we have nested structure also, which is a structure inside another structure. Like you can see here, struct date. Now inside I put integer, day, month, year. Then I have another structure named student, where it is written in roll number, start date. So this is known as nested structure. What is a nested structure? It is a structure inside another structure. So now we'll see one example here. Like first hash include, then we are defining a structure as struct student, and then we are writing the members. First member is integer roll number. The second one is char name. The size is 20. And the third is float marks. And now we have closed this. Okay, so now we have defined the structure. The first step is defining a structure. So this is how you define it. Now, second is int main. Now, the second will be inside the main function, which is the starting point of the function. Now, the first step is defining the structure. The second step is declaring and initializing the structure with a variable. Now, you can see, now the structure name was struct student. Now, I'll take the first member, that is S1. I'm giving the S1 name. Now, the first thing 101. What is 101? It is the roll number here. Then it is the name here, Harshit. Uh, that is the character name. Then we have float mark, that is 89.5. That is the float marks. So this is how you write it. First, you have to define the structure here at the top. Then inside the main function, you have to declare and initialize the structure. And now the third step is to access and print each member. So how you have to print is the normal way, printf roll number percentage d slash n. But at the end, you have to write is S1. Why S1? Because we are accessing and printing member of S1 only now. So S1 dot roll. Why roll? Because we are printing the roll number. And for writing the name, if you're writing the name of S1, so S1 dot name. Why name? Because the name. And S1 dot marks. Why marks? Because float marks. So this is the simple program which everyone can understand. And here's the output of the program. Roll number is 101. Name is Arshit. Marks is 89.5. So this is the code you can see here, and this is the output of the code. So this is the most simplest code which I can explain. So this is all about structures here, and now let's move on to the unions. So basically, union and structure are both same only, but only a key difference is there. For like in union, all the members have same memory location, whereas in structure, each member has its own separate memory. Okay, like here you can see the int role, the character name, the float marks in the structure has their own separate memory. But this is not the case in unions. They all have the same memory only. And the memory is given to the highest member, which is the highest memory size of the bytes. For example, there is a character that is a 1 byte, and there is an integer that is a 4 byte. So basically, the memory will be allocated to the character only because no, to the integer only because of the more number of bytes. Okay. So this is the main key difference. But nowadays we don't use unions much because we don't have issues with the RAM and the memory. It was used earlier, but yeah, we have to study it. So this is the syntax of the union. The same way, like we wrote of the structure, exactly same. Then we have this is how we have to write. Yeah, this is the example of how size is given. So unit data int type float as character ps. So int type is of 4 bytes, float is of 4 bytes, and character ch is of 1 byte. So the size of union is 4 bytes, and a structure it will be 4 plus 4 plus 1, 9 bytes due to more padding. Why 4 bytes? Because in union you can see the maximum number of bytes is 4 only. So it will be given the largest number to 4 bytes, largest number. Okay. And in structure, what will be the size? It will be each one has separate memory now. So 4 plus 4 plus 1, that is 9. So this is the key difference between structure and union. Union has a shared memory for all members. Structure has separate memory for each member. Size is like sum of all number in structure like I did earlier. And in union, the size is of the largest number and only one number of a time can be accessed. And in union, all the number can be accessed at once. So this is the basically this is the key difference, and this is the code where you can see hash include. Now defining the union inside the main function. Here we are calling union data D, member D. Now we are finding the value, initializing the value, printing, and this is the output. So this is the thing. This is the thing. Now, like this is the questions as well. You don't need to see that. It's a union only. Like you can see one example, like hash include stdio.h. Okay, so you have to like this is the question here. We are using hash include stdio.h, union xyz. Now you are initializing the and here inside the main function, we have taken a member s, and this is the thing. Now what happens is that in union, like 4 is written and we have 5. So it gets overlapped. After 4, it will get 5, and after 5, it will get 6. So basically, this gets overlapped on this. So whenever we print, we'll get the value of 6 only because the memory gets updated in union. Because in union, only the largest member has its memory. So, like in structures, each member has its own memory. But in union, the member having the largest byte size will has the memory. So basically, it is getting updated here. First, it was 4, then it became 5, then it became 6. So whenever you will call the function, rather it will be dot like integer A, integer B, integer C. It will print 6 only. Okay. So this was a function. And the last topic is pointers. So pointer is nothing but it stores the value of another variable of a particular data type. Okay. It stores the value of another variable of a particular data type. And this is the syntax. First, you have to write the data type like int, then you have to give a star and a pointer name. Like I am giving pointer name as uh bread. Any name. Now this data type indicates the type of data, the pointer, and star is used to declare a pointer. Okay. So this is the example of a pointer. You can see here I have written int a is equals to 10. The value of 10 gets stored inside a. Now we have to declare a pointer that is int and star p. Now p is equals to add the and a. What is the meaning of and a? It means that it assigns the address of a pointer to p. So is a normal integer variable, a is a normal integer variable, and a means address of a. So address of a is getting assigned to p, and p star p is a pointer. P is a pointer of an integer, and it stores the value of address a. Okay, so basically it got the meaning that it stores the value of another variable. So here p is storing the value of a. Okay, so how to access this? To access this, we have you can see here. This is how you access the pointer. So this was all about the C program I have learned till now. Till today, I've learned the pointers. So this is the C program and my assignment that I've learned till now. It is like a one-shot video, and these are the notes which I made with my hand. I hope you like the explanation. So today we will learn about C language. Like this will be like a one short video of a C language. So we'll start from the very basic. Like what is C? So C is a programming language. It was developed by Dennis Ritchie in 1972, and it is one of the oldest programming language. But it is so efficient that it is used in now our generation also. So we'll start from the very basic. Like what are variables? So variable is a container which stores a value. Okay, so like here you can see like a is equals to 3. So this value of 3 is getting stored inside a container, which is a. Another example is like 4.7. So this value of 4.7 is getting stored inside b, and c is equals to a. This single character is stored inside c. Okay, so c is assigned with a and b is assigned with 4.7. So whenever we'll call b, like b, what is b, then this value will get print. Okay, so like in kitchen we have containers storing rice, dal, sugar, like that. These are the containers which stores the value. Let it be integer or a character, anything. So this stored value can be changed during program execution also. Like when we execute the program, we can change these values. Okay. So now we'll learn some basic rules for naming variables in C. So the first rule is the first character must be an alphabet or underscore. The character starting must be an alphabet or underscore. This is underscore and this is alphabet. Now second is there are no commas and blanks allowed. Like in between the name, there are no commas or blank allowed. Like you're writing something and you have given comma. This is not allowed. Either it should start with underscore or alphabet. And no special symbol is allowed other than underscore. Like question at the rate and question mark, exclamation mark, nothing. Nothing is allowed. Like dollar and all. Only underscore is allowed. And variable names are case sensitive. Case sensitive means like if you are writing in a lower case like a, so this should be written in a only. You cannot say like you are first writing in a, and when you are printing the function, you are writing capital A. This will not work. So the variable should be case sensitive. So this is the first topic, variables. I hope you understand the topic. It was a very easy topic. So like how to write the name, I'll tell you. First you have to write the data type. Okay. Then you have to write the variable name, the name you want to keep. Okay, variable name. And the value will come the value you want to store. The value. Okay. So for example, I'll write one. Uh, for data type, I'll take integers. So integers keyword is int. So here I'll write int, and then I want the variable name. So I'll take age. Okay. So I'll write in small. So int age is equals to now I want to store a value. So I'll write my age like it is 19. So I'll write 19 here. Then I'll end it with a semicolon. So this is how you write a variable. Okay, this is the way you write the variable. Like first the data type, then the variable name, and the value you want to store. And at the end, you have to end it with a semicolon. Like you can write an example also. Like for example, this time you want to write a character. Okay, so keyword for character is char. So you have to write char, and I want to print like grade. Then I write grade equals to no, it is a single character, so I have to write in single quotes A. This. So this is the data type character. Its keyword is char, and then I've given the name of the variable grade, and then I've given the value A. So this value of A is getting stored inside this variable. Okay. I hope you understand. I'll take the last example. Uh, let's say I'll take float. So float, and I'll write the value of pi. You know, pi at 22 by 7. So I'll write this. Okay. So float pi. That is 3.1.14. So this is the data type. This is the variable name. And this is the value we are assigning to this variable. So this value gets stored inside this. Like in kitchen, we have containers now storing rice, dal, sugar, and other ingredients. These ingredients are stored inside the container. So just like that, this value is getting stored inside this container. This container name is variable. I hope you understand this. I have told this very basic. So now let's move on to the next topic. That is, yeah, one more thing. Variables are like four types. I'll tell you further in the video. The first type is local variable. Local variable. And second one is global variable. Just keep in mind, I'll explain this again in the video. Third one is static variable. And like fourth one is register variable. So I'll like give you overview right now. This local variable is declared inside a function. Inside a function means inside the program, inside the main function, okay? Inside the main function, and it is accessible only there. And this global variable, what is this? It is declared outside the function, like outside the main function, and it is accessible throughout the life. Like we can call it anytime. Okay. And what about this static variable? The static variable is it retains value between function calls. And this register variable is it is stored inside CPU register for faster access. And this is optional. Now I'll explain all this further in the video. For now, I've just given the overview. Now just keep in mind that there are four types of variable: local variable, global variable, static variable, and register variable. Now we'll go to the new another topic that are constants. This is also the very basic. We have to understand this. So constant is an entity whose value does not change. Okay, the meaning of constant itself is the value whose value does not change. So, what is variable? Variable is an entity whose value gets changed. It's just vice versa. Okay, so there are like three constants like integer constant, real constant, and character constant. Integer constant means 1, 2, 3, 4, like 1, 6, 7. There are no point, no decimal are there. What are real constants? Like 322.1, the decimals are there. Okay. And what are character constants? Character constants in the sense mean the special characters. And they are enclosed in single quotes. Like special character means like dollar or without specific like alphabets also, like A or at the rate, something like that. If you're writing like B also, na, then you have to enclose it with a single quote. Okay. This is the character constant, and these values does not change. Okay, like for example, I'll take C. This is a character constant. I'll take at the rate, character constant. I'll take capital D, character constant. I cannot write this without a single quotes. Like in integers, we can write 1, 6. Okay, but in this we cannot write that A. We have to write it in single quotes only. Okay, so this is about the constants. Now there are like keywords. I told you about keywords. Like yeah, and one more thing about this constant and variable, I'll tell. Like in variable, we store dynamic data. We can change it, na? This in like in variable, we store dynamic data. We can change it during the time of execution. But in constant, we store fixed data. This data is fixed. Okay, you have to keep in mind this data is fixed. Now we'll talk about keywords. What are keywords? In variable, I give you the example of storing now. Like I told you, like int age is equals to 12. Okay, so what is this int? This int is integer. Okay, this int is integer. This is the data type of the age. Like I'm writing 12 now. This is the data type. And to write this data type, I write the keyword. We cannot write like integer age. This is the wrong way. Like integer age is equals to 12. We cannot write like this. It will show the error. So we have to use keywords. Okay. For integer, the keyword is int. So like while printing, I'm writing int age is equals to 12. This means that integer age is equals to 12. Int means the keyword. Okay. So now I use the like I use upper I use char also. So I'll explain char also. Like char name is equals to like say Harshit. Okay, my name. So what is this char? This char is the keyword. Okay, what does this mean? This means character. So these are the keywords. We use keywords to define a data type. Okay, we always use keywords to define a data type. There are 32 keywords. If I'm not wrong, there are 32 keywords available in C. Then what are those? See, these are. I told you about int. It is integer. This is double. What is double? Like I told you the float now. This float has the like fixed values. We can print this much values only. But in double, we can take more numbers. Okay. We can increase the precision. Okay. We can increase the precision. This is the simple we can explain. Like in float, like thing, this is the area of float. Okay. and this is the area of double. We can print more numbers in double. These are the numbers we are printing in float. So we can say like double has more precision than float. Then this is the break keyword used to break the program. This is a character, and this is the constant I told, and this is static. This is the if, while, volatile. What is void? Void when we don't want to return a value. So yeah, the float I told, this float and double are similar only. And unions, I'll tell about this in the later video. Switch, struct means structure. Enum, extern, register I told. Case, return is the when we want to return the value. Okay. And size of when we want the size of the uh slot for. Okay. Now we'll go to the first C program. Okay. First C program. So here it is included. The first thing we write is hash include stdio dot h. Okay. What is this? This is the preprocessor. Okay. This is the preprocessor directive. This is the preprocessor directive. This is the most important thing. Like we have to write this first, otherwise the program will not work. Okay. Then what is this int main? Int main is the main function. This is the starting point of the program. Okay. This is the starting point of the program. From here the program starts. Starting point of program. Okay. Now printf. Hello, I'm learning C with Harshit. This is the output statement. This is the statement which is going to get printed. Okay. So this is the output statement. Okay. And this return zero means like whenever the program successfully runs, it returns zero to indicate that it is successfully executed. Okay. This is the meaning of return zero. Again, I'll tell what is the meaning of return zero. It tells that the program is successfully executed. Okay. Now we'll end the program by these bases. So again, this include stdio.h is the first thing we write in the program. This is the preprocessor directive. Without this, input and output functions like printf and scanf won't work. I'll tell what is printf and scanf in further video. Printf means like when you want to print something. Okay, like I'm printing this statement. This is the output statement which will be get executed. And what is this int main? This is the starting point of the program. Okay, starting point of the program. We can write here void also when we don't expect a return. See, there are two things, int and void. In void, we don't expect a value to return. In int, we expect a value to return. So that's why we write return zero. Okay. So now I'll go to the basic structure of the program. All C programs must follow a basic structure. A C program starts with the main function, like I told here, it starts with the main function and executes instructions present inside. Each instruction is terminated with a semicolon. Yeah, this semicolon, each instruction, like if we don't write the semicolon now, then this line isn't getting terminated. This means like it's continuing. So it will give an error. So whenever we write a line, we have to terminate it with a semicolon. This keep in mind. This is the like basic mistakes of the beginners. When you write the program in VS Code or any online compiler, when you will miss a semicolon, it will give error and it will like literally take minutes or hours of time to identify like where you have missed the semicolon. Like it sometimes frustrates. Like keep in mind that you have to put a semicolon at the end of the line so that it is terminated. Okay. So now first, every program's execution starts from function only. Yeah. Just like I told, this is the starting point of the program. So yes. Then instructions are case sensitive. I told you like in starting also, like they are case sensitive. If you're writing small a, then you have to write small a further in the whole program only. You will not like I've written my name Harshit H, and then I'm writing Harshit H capital. So this is the wrong way. Okay, this is the wrong way. Then fourth, instructions are executed in the same order in which they are written. Yes. For example, like you have done one, two, three, and four. So like the time of execution, it will execute like this only. It will not execute like this. The order you are writing in that same order, the program will get executed. Okay. Now we'll go to comments. Like this is the one of the most important thing for users. Like it's for user understanding only. Like comments is like they're like the notes. Okay. Like you can see here. Like for the beginner, if he sees this now, he won't understand a single thing. Like I'm telling my experience, I didn't understand a single thing when I saw this. Okay. So to simplify this, we write comments. Okay. Command is written by like double slashes. Now now I can write anything here. Like I don't know what is this, so I've written preprocessor. Okay. So the person who will see this code, at least at the right side, he'll see the node. What is this? He'll get to know this is a preprocessor. And this thing doesn't get executed. Okay. This is the command. This is like the commands are like human languages which we write to understand the code. Like what is this? To remember the code. Okay. These are like nodes and these doesn't get executed. And for a good programmer, it is very important to write commands so that he knows what he's writing and what to keep a track. Like if some other person is seeing, like he gets to know what it is written. Like from int main, like I'll write only wait. Like this is a preprocessor. Like I'll write a different color so that it will be easy for you. Nice. Preprocessor. And here it is starting point of the function. And this is the output array. Yeah, wait. This is the output statement. Okay. Yeah. So these are commands. These will not get printed. These are for like understanding only. Like we'll see and understand. Okay. So now you have the basic idea of what are commands. Now we'll go and read this what are commands. So let's go. Yeah. They are used to clarify something about the program in plain or normal human language. Like I told, like the first person seeing the code, he won't understand a single thing. So we have to write a note in the human language to clarify that what it's written in the program. Okay. It's just like adding notes to a C program. Okay. Now, commands are of two types also, okay? Like for a single line command, there are two types, single line command and multi-line commands. In a single line command, the command starts with two forward slashes, okay? Two forward slashes like this. Okay. Information after these slashes are not executed. Just like I told, like after these slashes, information will not get executed. But for example, you are writing commands, okay? Now you are writing here and then you have given enter. So this will not be included in the commands. Now here comes multi-line commands. Like you can write like this to this. No information between these two now, these are all commands. Rather, it will be on the next line, next para, anything. These will not get executed. These are commands only. Okay. So basically, like when you are writing big note, you use this. And when you are writing short notes, you use this. Single line comments and multi-line comments. Now, single line comment starts with two forward slashes, and multi-line comment starts with this, a forward slash and a star, and then again ends with a star and a forward slash. This is a multi-line comment, this is a single line comment. Now we'll understand like how the code gets executed. Okay. Like, for example, you have a, I use like VS Code. I don't know what you use. You can use online compiler also, anything. Okay. So, like, in first VS Code, you have to write the code. Okay. A code. In VS Code, you have to write the code. So, like, this is VS Code. Then this code goes inside the C compiler. C compiler. What does a compiler do? A compiler is a computer program which converts a C program into a machine language. Okay. It converts a C program into a machine language. So, this is the code we have written. Now this compiler, GCC compiler, any compiler, this will execute it in the machine language and this will then get printed. Okay. This is how the code works. First, you will write the code in your VS Code or anything, any software. Then the compiler will convert it into a machine language. Then it will get executed. Okay. So now I think you have a like basic understanding of what C language is and how it gets executed. So now we'll go to library functions. A C language has a lot of valuable library functions which are used to carry out certain tasks. For instance, printf function is used to print values on the screen. Yeah, one is printf. Like I told here in the basic program, this printf function, this is the library function. Now, what does it do? It prints the like whatever is written inside these. This will get printed on the screen. Yeah, this will get printed. So this is a library function. Printf is a library function. Now we'll go to the types of variables. Okay. I told you types of constants, but I didn't told you types of variables. So I included it there. So there are like integer variables, like int a is equals to 3. I told you the example there only, okay? So here you just can revise. Int a is equals to 3. Now real variables, int a is equals to 7. Float 7.7, okay? Float is the value of decimals. Like you're writing 7 is integer. Now if you want to write 7.2, 7.3, 7.4. So this doesn't come under integer. This comes under float. Okay. Keyword is also float only. Sorry. FLOAT. This is a keyword. 7.7. Like this is the correct way. 24.3. Now, if you want to write more digits, then you have to use double. Okay. Double. 24.356. Anything lamba. Anything long. Okay. Now, character variables. Like, yeah, I told like char A is equals to B or char name is equals to Harshit, whatever. So these are the types of variables I told you before only. Now we'll go to the format specifier. Now please understand this thing very clearly. Now this is the also very basic thing. So what are format specifiers? So like here we are, see in the basic program we didn't use any data type or any keyword. Okay, this is the basic thing we write wanna print. But in programs like we have to write the keywords and all, and to execute them or to print them, we have to use format specifiers. Okay, like the same, like for integers, we use keyword na int. Now for to print int, we have to use a format specifier, and that format specifier is percentage %d. I'll explain it from the very basic. See, first I'll show you with these are the format specifiers. Like for int, it is percentage %d. Like for float, it is percentage %f. For double is LF long float means LF means long float. So double means double precision float. I told you na like in float there is a limited value you can print, but in double you have more precision. You can print more values. So basically, the specifier means LF means long float. So it is double. Now for character it is percentage %c, and for character of string it is percentage %s. In unsigned integer it is percentage %u. Long integer is percentage %ld. Okay, and all this. Now I'll explain this to you in very basic thing. I'll write here integer array. Wait a second. Integer. This is a data type. Okay. Now to write this, we'll use the keyword that is int. And now to print this int, we'll use the format specifier. Okay, that is percentage %d. Understood? The most simple thing I've explained. This is a data type, and to write this data type in the program, you have to use the keyword. And to print this keyword, you have to use the percentage specifier, that is percentage %d. Like this thing, like this only thing works. Okay, this is the only way things work. And I'll explain for character also. Same way. Like character is a data type. What is it? It is a data type. Now, to write this, we have to use a keyword that is char. And now to print this, we have to use the format specifier that is percentage %s. Simple thing, data type. To write this, we use keyword. To print this, we use format specifier. The most simple thing. Okay. Now you understood? So now format specifier is also very clear in your mind. The most basic thing to write, to write this, to write this keyword, we use format specifier. Now what is this? This thing is to add a new line. Like I'll tell in the program, but just keep in mind that a forward slash and a small n means new line. Now again, like I told you, that printf is printf prints the function the same way there is scanf that takes the input from the user. Okay, whatever you want, like you have seen, like you open the Facebook, right? You open the Facebook. There are two things. User login credentials. There are two things. First is your username, and another is your password. So what it is doing, it is taking your input only, na? You have to write your username first, then you have to write your password. So this is what is this? This is the input. So basically, scanf, what is scanf? It is used to take the input from the user. And what is printf? Printf is used to print the function. Now, what is the syntax? I'll tell you the syntax. Now, syntax is nothing very simple, like scanf. Ignore this. Right now, I'll take in this of this example. Ignore this. Just scanf, okay? Now, like we'll go to another thing. The first page is over. I hope this whole page is clear to you. Now, program one. Okay. So in program one, you can see here, first it is written hash include stdio dot h. What is this? I told you previously, it is a preprocessor directive. Okay. Without this, this printf function won't work. Without this, that scanf function won't work. Okay. Now, like, yeah, I told you about int main and void main. Na? I'll show you with example here itself. Okay, so that it gets clear in your mind. So here it is written void main. Okay, the function starts from here. Okay, this is the starting point of the function. So what happens in void is void means it returns nothing. It won't return anything. Okay, like it int you have seen it was written like return zero. Like the same thing, void means just execute the program. Don't return any value. Okay, just execute the program. Don't return any value. These two programs are exactly same, but the difference is here it is void main and here it is int main. So now you understand the value meaning of like what is void and what is int. Int means return a value, but void means don't return anything. Okay. Now like what happens today is like there are compilers I tell you before, like the modern compilers are like GCC and Clang. These accept or like they prefer int main. Okay. Like they prefer int main. Now like standard wise, we if we say standard wise, then you can use int main because like it's like more preferable. But if you want don't return any value, then you can use void. Okay, this is the only main difference between int main and void main. Now printf hello world. Now this will get printed because of this function. This means you have to print a value, and then we'll terminate with a semicolon. Now program two, the same, exactly same program. Okay, printf this value will get printed. Just return zero is written here because if the program is successfully executed, then it will return the value zero. And int main means returns the value. So that's why it return zero. Here it is no return value. Okay. So I hope the void and int is clear to you now. Okay. See, I've written here also for you. Include stdio.h is a preprocessor directive. This thing, this whole thing is a preprocessor directive. Without this, compiler wouldn't recognize the scanf and printf function, this printf function and scanf functions. Now, int main is a main function. It is the entry point of any C program. Void main means it doesn't return any value to the operating system. Like I told here, void main won't return any value to the C program, and this is the starting point of the function. Not return zero. It returns zero when value when program is successfully executed, and zone zero when it is indicating an error. Okay, like this one I told. In int main, if the program is successfully indicated, it will return the value zero. But if there is any error, it will give any non-zero value, like to any non-zero value. Let's take one. So I hope this basic program is now clear in your mind, and now you can at least print your name or print hello world in the C. Okay. Now let's go to Mantissa. Now, what is Mantis? I'll tell you. Like, you must have studied maths. You write there, no? Like 4.5 into 10 to the power 2 or 5 into 10 to the power minus 2. So, in C, we use Mantissa exponent. You know, what is a Mantissa exponent? I'll explain. Mantissa E exponent is a real number expressed in either decimal or integer notation. Like, here you can see. It's written 4.5 E2. What is 4.5 E2? What does this mean is 4.5. E means 10 and 2 means power of 10. So what does this forming? It's forming 450. See here, E2 means E is 10 and 2 is power. So 4.5 into 100 is 450. This is the way you write it. Now let's see 4.5 into E into minus E. What is E? 10 and minus E is value. So 4.5 into 10 to the power minus 3 is equals to 0.0045. This value. Okay. Now let's take 25 into e to the power minus 3. I'll take in so many examples. So like it gets clear in your mind in one time only. Okay. So 25 e to the power minus 3. That is 0.025. See here. 25 as it is, we'll write 25. E is always 10. 10 and minus 3 is its power. So you can write any digit. Like you can like I'll take a random example like 500 e minus 3. So 500 into 10 to the power minus 3. Simple. 0.5. Like this is the Mantis. I hope this is clear to you. This is a very simple and basic thing, and that I'm telling to you. This is the most simplest thing. What is E? E is 10, and after that value E is its power. Let it be 3, minus 3, 2, 10, anything. Okay. Now we'll go to declaration in C. So this is the way you declare a variable in C. This whole thing you can see. I'll explain it to you. Now, first I'll tell you what is declaration. Okay. Declaration means it tells the compiler about the name and type of variable or function before it's used in the program. Okay. Declaration is it tells the compiler about the name of the function like this, about the name, about the type, what is its data type, what is its name before it's used in the program, before using in the program. Okay. So basically, we are telling the program, see this we are telling name and we are telling the data type and all. So how to declare a variable in C? Like first, it is written int a semicolon. Why a semicolon? Semicolon is because we have to terminate it. Okay. So now this is the comment we are using, like I told you previously. So int a means declare integer variable a. Okay. Integer means int, variables mean a. So this is the way you declare. Declare integer variable a. Okay. Now what is this? Declare float variable b. Simple, right? Float b, this thing. Okay. Now int I is equals to 10. Now you have to learn about initialization also. Initialization is like giving the value. Like we were giving in previously, na, A is equals to 3, B is equals to 3. This is initialization. Okay. So first we declare, then we initialize. First we declare, then we initialize. So I've included in the same program only so that you can understand very nicely. So how you declare? What is the meaning of declare? First, again, I'll tell you again. The meaning of declaration is telling the compiler about the name and type of variable. So name is a and type of variable is integer. So int. So int is semicolon. Okay, so this is we are declaring an integer variable a. Float b, we are declaring a variable which is float. Now we'll take int I equals to 10. I'll tell you about initialization. First we declare this int I. I've declared it. Then I've given it a value of 10. I have assigned the value of 10. So this is initialization. So declare and initialize I with 10. This I with 10. I hope you understand this. Then again, I'll take int a is equals to 2 and b is equals to 3. So first declare and then initialize multiple variables. Multiple means a and b with 2 or 3. I hope you understand this thing. I'll tell you once again. I'm declaring an integer variable, int a. This means declaration, telling the compiler what type of data type, what type of variable it is. So this is how you declare float a, int b, anything. And then you have to initialize. Initialize means giving the values like int I is equals to 10 and int a is equals to b, int a is equals to 2, b is equals to 3. This is how you declare in C. The program name, experiment one. So the question is design and develop a flowchart or algorithm to accept three coefficients a, b, c of a quadratic equation ax square plus bx plus c is equals to 0 and compute all possible roots. Implement the flowchart and algorithm in C and output the roots with appropriate messages. So this is a question. This is the program we have to execute. So for this, we should know what is a quadratic equation. So quadratic equation is ax square plus bx plus c. This is our quadratic equations. So the quadratic equation are calculated using this formula. This is the formula to calculate quadratic equation. So this thing is known as discriminant. So d is equals to b square minus 4ac. Then d, if d is lower than 0, then we'll get two real and distinct roots. And if d is equals to 0, we get real and equal roots. And if d is greater than 0, that is negative, we get two complex roots. So to get real and distinct roots, d should be positive, and to get real and equal roots, d should be equal to 0. And for negative, d should be less than 0. So we'll start our code here. This is the preprocessor directive. And this we are using this include math.h library function for square root because in this program we'll do some calculations, so we need this library functions. Int min is the opening point of any program. So here, this thing we are declaring a variable here. So float A, B, C are the coefficients, and discriminant I told you only what is discriminant. So this is discriminant here, and root one and root two are for storing roots. and this is real part and imaginary part. So the first step is to take input from the user. So we'll this printf enter coefficients A, B, and C. So on the screen it will display this. Then we'll take input from the user using scanf function. Percentage F is format specifier for float, and we are using AND A, AND B, and AND C to store the address of this coefficients. The second step is to calculate the discriminant. So what is the formula for discriminant? It is b square minus 4ac. So b to b square minus 4 into a into c. This asterisk, this is known as asterisk. Then the third step is to check nature of roots. So I already told you the logic, how to check. If d is positive, then it's real and distinct. If d is equals to 0, then real and equal roots. And if d is negative, then we have complex roots. So in step three, we'll check if d is greater than 0. If in case it is greater than 0, then they are real and distinct roots. So root 1 and root 2. So if they are real and distinct, then we'll be print roots are real and distinct. And this is percentage point 2f. This means this is the format specifier for float, but for double precision. Like after decimal, we will have two values. So percentage point 2f means after decimal, we have two places. Okay. This is for double precision. Then if this is not the case, then discriminant will be equal to 0, and that is real and equal roots. So root 1 and root 2 will be same. So minus b by 2a. Then we'll print this also. And if this is also not the case, then we have the x, that is complex roots. It will be negative, so minus b by 2a. And this is how we'll print it. And after that, we have return 0. Why we use return 0? Because of this int main. Because we are expecting a value in return. Uh, So if program is executed successfully, then we'll get 0. And if we have some error, then we'll get some non-zero value. Okay. So this was the code. Now we'll execute this in the compiler. And this is the flowchart of this start and the coefficient will discriminant. This is the flowchart. So let's now go and execute this program. this is a program too. So we are again given a quadratic equation, and we need to write a C program that takes input values for A, B, and C, then calculate the print route using formula. So this is similar to the first program, but here basically it focuses on formula and implementation and computation. So let's recap the formula again. So uh, discriminant is equals to uh, b square minus 4ac. And then we have the roots. If d is greater than 0, then it is positive, so real and distinct roots. If d is equals to 0, then it is real and equal. And if d is less than 0, then it is complex root. So we'll come to code again. This is the preprocessor directive. This is the library function. So because we are going to find square root, so we need this library function. This is the opening point. Here we are declaring three coefficients a, b, and c float, and here we are declaring other variables. Discriminant. It's same like the previous program, so I will skip it fast. Uh, Here, we are taking input from the user. The three coefficients. Discriminant. If discriminant is greater than 0, then we have real roots, real and distinct roots. We execute this, and if we have discriminant equals to 0, and in this case, in this whole case, we have real but equal, real and equal roots. And in this case, we have complex roots. And again, return 0 because if the program is executed successfully, then it will return 0. Okay. Why? Because we are using increment. So let's move. Let's move to the execution of the program. Yeah. So let me connect my mouse. Wait just a second. So let's copy this code from here. I think we can't. We can. Yeah, we can copy. It will save our time basically. Command C. So basically, the program will be same. So let's run this program out. Error. Oh, yeah. And the we can change this. So it's the 2, 3, and 5. So here are the roots. The roots are complex, so root 1 and root 2. Again, we'll take more time, then we'll move to the next one. 6, 8, 6, 8, and 9. Here are the roots. So now let's move to the other program. Where is the third experiment or third program? The program is write a C program to relate two integers using equality, greater than equal to, and less than with nested ifs and multiple ifs. Okay, so let's start it. So first, what we'll do, we'll take two integers as input, then we'll compare them using equal to or greater than equal to or less than. So we are going to use nested if and multiple structures to decide and print the relationship. So here's first code, and here I've taken the alternate version, which is using nested if. So first, let's see a code. Uh, this is preprocessor directive. This is the opening point of the function. Here we're declaring two numbers, number one, number two. So in step one, we'll take input from the user. So enter two integers, percentage v, percentage v. So number two and number two, number one, number two. So the first program we are writing is using multiple ifs. Okay. So in this, we write and if number one is equal to number two, then print number one is equal to number two. If number one is greater than number two, then print that number one is greater than number two. Or else number one is less than number two. So this is the simple program, very, very basic program. This is very basic using multiple if. Okay. Now coming to the nested if version. So here again same. Purpose of the directive. Opening point of the function, declaring two numbers, taking inputs from the user. So here in this case, number one is greater than equal to number two, then number one is equals to number two. Okay. Else print that number one is greater than number two, or else print number one is less than number two, and then return zero for intent. So I hope you understand this program. So now let's execute this program again. So we'll just copy the code because I've already written it here. So let's make this copy this code and yeah. So, so here again, people select the directive. Then this is the main function. Then we'll take input from the user here. Percentage D is format specifier for integer. Then we are using multiple if here. Okay. So now let's run a program. Error. Achha, wait. I have two written zero here. Now it will run. Enter two integers like the 3 and 5. 3 and no, 3 and no 5 and 6. 4 and 5. 4 is less than 5. Okay. Then this will take 7 and 3. 73. Wait, wait. 73 and 56. And 73 is greater than 56. Okay. So this was our code using multiple if. Now let's see our code using nested ifs. So this is our code using nested if. Now let's run this code. 4 and 6. 4 is less than 6. Okay. So this was our code, both the code. Now we move towards the code. So this is experiment number 6. So in this we have to perform binary search. So basically what is binary search? Mm, so binary search is a fast searching algorithm. It only works on sorted array. Sorted arrays means your array should be either in ascending order or should be in descending order. It should be arranged. It should not be random, either in ascending order or either in descending order. So we have to first find the middle element of the array. And to find the middle element of the array, we have a formula that is first term plus last term, first term plus last term by 2. By this, we'll find the middle element. Okay. Then if the search value is equals to the middle element, then it is success. So we'll execute the program and exit. But if this is not the case, then we'll search the left half. And if we didn't found, no, if the search value is less than the middle element, let's suppose this is the middle element, first element and last element. If the value is less than the middle element, so we'll search on the left half. If the value is greater than the middle element, then we'll search on the right half. But if the value is equals to the middle element, then we'll exit the program by printing this. Okay. So we repeat this until the array becomes empty or we found an element. So this is the logic of the binary search. So now let's move towards the code. So first we are previous the directive, then we are declaring some important variables. Then we are taking number of elements here, input from the user. Then this is for uh, sorting the numbers in like ascending or descending order. Then we have to enter the search or the key which we want to search in binary. For example, let's take 5. So we want to search number 5. So it will search 5 in the whole program. Okay. So in this case, in binary search, we use like the number of terms are 5. So we use indexes like 0 to 0 to n minus 1. So suppose number of terms are 5. So 0, 1, 2, 3, and 4. These are the indexes of the array. Okay. We take from 0 to n minus 1. If n is equals to 5, then 5 minus 1 is equals to 4. So 0, 1, 2, 3, and 4. This is how we take indexes. So we have to use this while condition here. And then the first thing is if the array is the middle element is equals to the search, then then the position is found, and we'll exit like break. We'll exit the program. But if the target is less than middle, then suppose this is middle, this is the first term, this is the last term. If the target is less than middle, then you have to search the left part. So for this, we use this formula, that is last is equals to middle minus one. So this last comes here. So we'll search this left part. And if the search is on the right side, so we have to plus this middle minus one. No, sorry. If the key we are searching is on the right side, then we have to do middle plus one. So we'll search it here. But if it is on the left side, then we have to search it here. For here, it is the formula middle minus one. So this is the logic here using. And if it is not the case, then we'll do if condition first greater than last and percentage d, the element is not found in the array, and then return zero. So I'll explain this again nicely. First, we have middle element. This is the first and last element. If the search is equals to the middle element, then we'll break the program and execute this. But if the key or the element you have to search is on the left side, then we'll use the formula middle minus one. Middle minus one. So here we'll search in this part. Okay. But if we have a key on the right side, then we'll use the formula middle plus one. So we'll search on this part. Okay. So this was the logic. Now let's execute this code in the compiler. And here is the flowchart of this. C start, then we have to input size and array. Then we have to input the search element which you want to search. Then C, middle plus first plus last by two, finding the middle element. Then C, uh, if it is greater than equal to search, then we'll use middle first equals to middle plus one. Then if not, then we'll search on the left side. So middle minus one, and the end of the program. So this was the flowchart. Now let's execute this program here. So wait. Now let's copy this code which I've already written to save some time. Yeah, run. Send a number of elements. So I write 22, 33, 44, 55, 66, and 77. Okay. And the 22 integers in sorted order. Wait. Uh, First, you have to enter number of elements, like 5 elements. Okay. In sorted order. So I'll take 3, 4, 5, 6, 7. Okay. Enter. Now, if I want to search 5, this is the middle element. Okay. So it will give founded position 3. Okay. Now let's clear this, run it again. 5 elements again. 1, 2, 3, 4, and 5. Now if I want to search this like 4, it will get it responded at position 4. So this was our program. So this is our experiment 5. So it is write a C program to generate the Fibonacci series from a given number n. So this series is a sequence of numbers where each number is sum of preceding two numbers. Means 7 is sum of 6 and 5 preceding two numbers. Okay. So it starts with 0 and 1. So you can see f of 0 is 0, f of 1 is 1. So sum of two preceding numbers, it means n minus 1 and f of n minus 2. So now I think you have an idea what Fibonacci series is. So let's go towards the code. This is the preprocessor directive. This is the opening point of the code. So now, first, what we are doing is we are declaring we are declaring variables. So first, I int n, which means no, n means number of terms here, n means number of terms, like how many terms are we giving? And first means zero, and second means one. And next is to store the next number. This is for to store next number. And this I is the loop counter. Okay. So now first we'll take input from the user. How many numbers he wants, how many terms he wants. So this is for taking input from the user. Input will come from scanf. First it will print on this screen this thing. Then he'll enter the number of terms. Then print Fibonacci series. Then we have this loop for the series, that is I is equals to 0, I is less than n, and I plus plus updation. So if n is less than equals to 1, then the first two terms are directly 0 and 1. Okay, this means loop will run n times, and this means that the first are 0 and first two terms. First term is 0 and second term is 1. But then else next is equals to first plus second. And the first term is 0, second term is 1, and from the third term will you go for next. Okay, that is first plus second. So this is what we are going to use. Then after that, we'll go for updation. That is first is equals to second and second is equals to next. Next means this thing. Then we'll end the program and then we'll print every number, every term. Okay, and this is the flowchart for this program. So now let's go and execute this program. Let me connect my keyboard. So let's first copy this code. Mm, We can't see. So this is our code. Again, int n is number of terms. First term is 0, second term is 1, and next is first plus second, and I is the counter loop. So now we'll run the program. Enter number of terms, enter number of terms. So like we are entering four terms, then this is the Fibonacci series for that. And if we are doing number of terms 7, then let's wait a minute. Wait, it's number of 5. Then this is the Fibonacci series. So now this program is done. Let's move to the sixth program. So now this is our seventh experiment. Seventh experiment. So basically, you have to perform basic functions like operations like addition and subtraction, but this time we have to use matrix operation. Okay. So what is a matrix? Matrix is basically a one common. Okay. So here in matrix we have matrix A. So this is the row and column. Okay. So basically this is the matrix. So you can see matrix. Okay. So let me first tell you concept that we are going to use in this matrix. That is matrix addition. So see, I is row, J is column. So matrix of A row column plus matrix of B row column, which gives C matrix. Okay. So this is how we do addition. In while doing subtraction, just you have to say change the sign. So this is how we subtract. And while transposing, what happens in transpose is row and column. Okay. So in this the row become column and column become rows. So this is not a transpose. Like you can see here, I becomes J and J becomes I. So this is the only thing. Now let's move to the program. So here we are declaring variables here. Okay. Uh, Next is we have taken matrix. Where for transport differentiation sum, now we'll take input from the user that what is the first matrix, that is A. So let me explain this for loop for you one time. So this is the wait. This is the outer loop, that is for rows, and this is the inner loop, that is for columns. Okay. I run for rows, that is outer loop, and J runs for column, that is inner loop. So now we take input of the second matrix also, element of the second matrix, that is I again rows, and this is columns. This is rows and this is columns. So now matrix addition. So we have two matrix now, matrix A and matrix B. So we basically we'll do nothing, just add this. And in for some of matrices, we'll add this. In matrix subtraction, we'll subtract this, and for differential matrices, we'll do this. And for transpose, I already told you rows become column and column become rows. So this is the transpose of the matrix and return zero for it successfully executing the program. So this is the basic simple code here. I'll execute and explain it there a little bit. So basically the flowchart is start the program, input rows and columns, input two matrices, perform addition, subtraction, and transpose. Then display the result and end. So basically this is the flowchart, simple flowchart. Now let's run the code. So let me connect my keyboard here until here. So I've already written the code here. Let's just copy this and go towards the So now we'll study some basic topics like storage classes in C. So what is storage classes? So a storage class in C define four things about a variable. Okay. First is scope, second is lifetime, third is default initial value, and fourth is storage location. So the let's see first one is scope, that is where the variable is accessible in your code. If, Scope is like where you can access your code, like inside the main function, outside the main function, like that. Okay. Now let's what is lifetime? Lifetime is how long the variable exists in the memory. Okay. This is known as the lifetime. Third one is default initial value. What value it has, if not explicitly initialized. Now fourth one is storage location, where it is stored in memory. So whether it is stored in memory or CPU registers, that is known by storage location. What is storage? Okay, so this was the topic of storage classes in C. So now we'll go to types of storage classes. So they have four main storage classes: scope, lifetime, default, sorry, auto, register, static, and external. So let's see first one auto. So the scope of auto is local. Okay, local means where you can access your code. Like you have studied three things, like three variables now: local variable, global variable. So in local variable, you have to write it inside the int main function, inside the int main function. And global variable means that you are declaring the function outside the main function and you can access that function throughout the code. Okay, that is known as global variable. So auto storage class is local variable and its lifetime is function and by function or block. Default value is garbage and its keyword is auto. Then comes register. It is also a local variable, same function block, garbage value, but the keyword is register. Now, static class, that is this thing is like local or global variable. Now the its lifetime is in an entire program and default value is zero and keyword is static. Now talking about the extern, it is a global variable. The scope is global and it is accessible throughout the entire program. Value is linked from the file and it is an external. Now, what is auto storage class? Auto storage class is the default class for local variable. It exists inside a function or block only. Okay. I told you about local variables. It exists inside a function or block only, and it is accessible inside that function only, unlike the global variables. Now, memory allocated is on the stack and not needed explicitly. Now, let's see the example. Void main curly braces auto int x is equals to 10. This is same as int x is equals to 10. Okay. Printf percentage x. So this value will get printed. So this is the example of local variable, auto storage class. Now the second one is register storage class. This tells the compiler to store the variable in the CPU register. What this does is we can access faster than the auto storage class. Now it is used for loop counters or performance. You cannot use address. Address means copying the address. This AND function means copying the address of one variable. Okay. So you cannot use AND with register variables. Okay. So let's see this example. Void main curly braces register int I. We are declaring this int I here. What is I? I is a counter loop or for loop. This is the counter loop. So I is equals to 0, I is less than 5, and we are incrementing or we can say updation I plus plus. Then printf percentage d I. Now we study about static storage class. So what static storage class does is it retains its value between the function calls. Its memory is allocated only once. Now it is useful for counters. Counters mean that I, which is written inside the loop now, for loop, that I is known as the counter. Now preserving state in recursion, global flags. Now let's move on to external storage class. It is used to declare global variables across files. Variable is defined elsewhere. You are just referring to it. It don't allocate memory, just references like a global variable. These two are the examples of it. Now, let's summarize everything what we studied till now. Auto and register are the local variable. Its lifetime is till the function ends. The initial value of both is the garbage value, and auto is used for default value of local variables, and register is used for loop counters, speed optimization. Now comes the static and extern. Static may be local and may be global, but extern is always global variable. Their lifetime runs throughout the whole program. The initial value of static is 0, but the external but the initial value of extern is from external, like we link it from the code. Now, static helps in maintaining state across function calls, and external helps in linking variables across files. So now let's move on to our second topic, dynamic memory allocation in C. What is dynamic memory allocation? So in C, dynamic memory allocation allows you to allocate memory at runtime. Runtime means during the time of execution. So during the time of execution, not at the compile time. So why do we need it? So we need because sometimes you don't know how much memory your program will need beforehand, like user-defined array size. That's why we use dynamic memory allocation. It also helps in manage heap memory efficiently. So where is now memory allocated? So we have types for that, like static and global variables and local variables. So static and global variables are in the data segment. Local variables are in the stack, and dynamically allocated is in the heap. So now let's move on to the malloc memory allocation. Its syntax is ptr pointer, bracket cast type star, malloc size underscore in underscore bytes. So this is the example where we are declaring a pointer star ptr. Now here we have used this malloc and size of int, which allocates memory of 5 integers. This is the for loop for that. So here memory is not initialized. It contains garbage values. Okay, it contains garbage values. Now, after the malloc C, we have calloc C, that is contiguous allocation. The syntax of that is same, just instead of malloc, we will write calloc. Okay. Now, example is in int star ptr, that is pointer. Pointer is equals to int star calloc, 5 size of int. That means we are allocating and initializing it to 0. And here is a for loop that will print 0, 0, 0, 0, 0. So here memory is initialized to 0. Now we have realloc, that is reallocate the memory. It is used to resize previously allocated memory, and the syntax is pointer is equals to realloc ptr new underscore size. Here is example ptr realloc pointer comma 10 into size of int. That means now we have space for 10 integers. Now it keeps the existing value and will add more space. Okay. It will not delete the values, it will keep the existing values and will add and will keep adding more spaces. Okay. Now we have free, that means free memory. Free is the memory block previously allocated by the malloc, calloc, or realloc. If you have allocated the memory using malloc or calloc or realloc, then freeze will then this free function will free the memory block which was allocated by these three. Okay, the syntax is free PTR, that is free pointer. Now we should always use free after you are done to prevent memory leaks. Okay, so now let's move to the third topic, file handling in C. What is file handling? In C, file handling means reading from and writing to files on your disk using a set of standard library functions. This allows you to store data permanently, access and process large data, share information between programs. So now why use files? So without files, like data is temporary. With files, data is permanent. Without files, uh, data is lost after the program ends. But with files, we can save the data for use purpose. We can't handle big data without files, but we can read and write huge logs of code with files. So what are the basic steps in file handling? So first we have to declare a file pointer. Then we have to open a file using fopen. Then we have to read or write data using functions like fprintf, scanf, fgets, etc. Then we can close the file using fclose. Now how to declare a file? Pointer declaration. That is, first you have to write file, then for pointer you write star fp. This is the way you declare it. Okay. Now what is file? File is basically a structure defined in stdio.h. Okay. File is a structure and star fp is a pointer to file. This file is a structure and this is a pointer to file. Now opening a file, that is fopen. Fp is equals to fopen, then bracket, file name, comma, mode. Now what is mode? Mode's opening file, that is R, W, A, R plus, W plus, A plus. R is read mode only, that file, but for this read mode, file must exist. W is write mode, A is append mode, R plus is read and plus write. W plus is write plus read, that is override. Then A plus is append plus read. Now using fprintf, this is the syntax. Um, we use fputs only for these strings. Okay. Now same for reading files. This is the using fscanf, and this is fgets only used for string. And if you want to close a file, you will use fclose. This is how you will close a file. First you have to write f close then fp. This frees up system resources, and we should always close files to avoid the data loss. Now other file functions we will see, that is fgetC, that is it reads only one character. FputC, which writes one character. Fgets, which reads strings until new line. Okay, fgets will read a string until new line. Now we have feof, that is which checks the ends of the file. Then we have fseek, which moves file pointer. Then we have ftell, which tells current file pointer position. Then we have rewind, which moves pointer to start. Now let's see some common mistakes we do. That is not checking f open results, which can cause why if we don't check, then what will happen? It can cause crashes. Then forwarding f prose. What happens? Memory or resource can be leaked using wrong file mode. What happens? It might override or fall silently. Okay. Now let's move on to the new topic, that is preprocessor. So what is a preprocessor? You must have seen during the start of the program, we write hash include stdio.h or include string.h or math.h. These are the preprocessor. Without this preprocessor, the printf function and scanf function won't work. So before your C program is compiled, the C preprocessor scans the code and performs some actions. These actions are preprocessing directives. Preprocessor directives begin with a hash, that is this symbol, and they are not C statements, so we'll not put any semicolon on it. Okay, and they are executed before actual compilation begins. So what does it do? It includes header files, it defines macros, it conditionally compiles code, it replaces symbolic constants, it removes comment. Okay, now the list of preprocessor directives. As I told you earlier, hash include, hash define, hash undef, hash ifdef, hash if and def, hash and if, hash else, hash elif. So what hash include does is it includes header files, and what hash define do is it defines constants or macros. What undef do is it defines a macro, and what this thing do is it does conditional compilation, and it also does conditional logic like if else this thing, and Pragma does compiler specific features. So now let's move to hash define. What is hash define? It is used for defining constant or macros. This is a macro and this is its value. This is a macro and this is its value. Okay. Now we have the fifth topic, that is enumerations and type def in C. So why to use enum and type def? It helps create more readable, maintainable, and self-documenting code. It replaces magic numbers and log type declarations and with meaningful names. So let's move to part A, enum, which is enumerated data type. So what is enum? Enum is a user-defined data type that allows assigning names to integer constants, which improves the code clarity and prevent errors. So this is the basically syntax of enum. That is, first you have to write enum, then we have to give a name to enum. That is enum underscore name. Any name can be given. Then we'll open the curly braces. Then value one, value two, value three. Like this, we'll close the curly braces. So this value one is zero by default. Value two is one by default, and value three is two by default. We can manually assign values like it is given here. See, enum, we are telling them we are writing enum, then we have given colors, that is name of enum. Then we can manually assign the values. Okay. So this is the simple example. Here enum is this, enum day is name of enum. And see, here we are assigning the values by ourselves. So now let's move to part B, that is type def. So what is type def? Type def is type definition. That is, type def lets you create an alias or nickname for an existing data types. It is used to make complex declaration easier to understand. So this is the syntax of type def. First, we have to write type def ourselves. Then we have to give a name to the existing type, new name. That's it. So now summary table. So enum has, what's the purpose of enum? Name integer constants. What's the purpose of type def? It is a nickname for data types or alias for data types. Example of enum is enum day, month, Tuesday. Example of type def is type def int age. The output is assigned integer values. This output is simplified declaration. Advantage of enum is clean switch case avoids magic numbers. And advantage of type def is readability, reduce code length. Okay, so now let's move to the last basic topic, that is bit manipulation in C. What is bit manipulation? So bit manipulation means performing operations directly on bits, that is zeros and ones of integers. So it is used for speed and memory efficiency, embedded systems, cryptography, network protocols, and competitive programming. So basically, C provides six bitwise operators, that is AND, OR, XOR, NOT, SHL, and SHR. So basically, AND has a name bitwise AND, OR is bitwise OR, XOR is bitwise exclusive OR, that is XOR exclusive OR, and is bitwise NOT. SHL is shift left, left shift, or SHR is right shift. So these are the symbol. Bitwise AND has a AND symbol, bitwise OR has this symbol, exclusive OR has this symbol, NOT has this symbol, left shift have this double symbol, and right shift has this symbol. So meaning of bitwise AND is like one if both bits are one. Okay, it will give the value one if both the bits are one. Exclusive OR is one if bits are different. Okay, both bits should be different and it will give one. And flip bits, zero becomes one and one becomes zero. In bitwise not, it flip the bits. If the bit is zero, it will become one. And if the bit is one, then it will become zero. Now left shift is it shift bits to the left, adds zero on the right. And its vice versa is right shift. It shifts bits to the right and moves right bits. So now the last topic, that is recursion in C. So what is recursion? Recursion function is a function that calls itself to solve a smaller version of the original problem. So it is like standing in front of two mirrors. The function keep calling itself until a base case is met and the mirror ends. So basically, we have two key parts of recursion, that is a recursive case and a base case. So what is recursive case? When a function keep calling itself, it is known as recursive case. And when this function the stopping condition of function is also known as base case. So here's the syntax of recursive function, that is return type, function name, and inside this bracket, there should be some parameter. Then we have curly braces. Then we have if case, if condition, and we have the base condition first. Then return result. Then we have else condition here, return function name. So this is basically the syntax of recursive function.